Hello and welcome in this course of analog communication. And today's topic of discussion is power contains in amplitude modulated wave in AM wave. So we will discuss every aspect of this power contains in amplitude modulated waveform. So let us start with taking one carrier signal in time domain. That carrier signal is represented as EC cos 2 pi FCT. So this is equation 1. This is unmodulated carrier. This waveform is representing unmodulated carrier signal. Unmodulated carrier. This EC is representing its peak value or amplitude of carrier signal. And this FC is frequency. This FC is frequency. And for sake of convenience, we have taken phase as 0. Phase is assumed as 0. Assumed as 0. And consider another signal, that is information containing signal or baseband signal, also known as modulating signal, which is also sinusoidal signal basically. So this is also EM cos 2 pi FMT. So this is equation number 2 representing modulating signal. And EM is representing amplitude and FM is frequency. So one important point we can note down, only one frequency component is present. So this is basically a single tone, a modulating signal. This is single tone modulating signal. Single tone signal. So we are going to produce amplitude modulated signal using one unmodulated carrier signal ECT, that is given by equation 1, and another signal is modulating signal. Suppose third waveform that is representing amplitude modulated signal is given by A cos 2 pi FCT. This A is amplitude of modulated signal. This A is modulated signal amplitudes. So basically amplitude modulation is the process in which we change the amplitude of carrier signal, or we make the amplitude of carrier signal proportional to modulating signal. So only amplitude of carrier signal is modified. This carrier signal amplitude EC is modified and frequency and phase will remain constant. This is the definition of amplitude modulation. So what we have done, we have modified only EC of carrier signal, that is amplitude of carrier signal, and the resultant amplitude is A. This A is representing amplitude of modulated signal. This A is basically EC. This is made proportional to modulating signal EMT. So this is representing A. This is representing A. This is equation number 4. This is equation number 4. Once again, I repeat, one waveform that is equation that is given in equation 1 is unmodulated carrier signal having amplitude is EC, frequency FC, and phase we have considered as 0. Another signal is modulating signal or information containing signal with amplitude EM, frequency FM. Only single frequency is present here. So this is single tone modulating signal, and we will produce third signal by the process of amplitude modulation, which is the modulated signal. So this modulated signal is given by this equation where A is amplitude of modulated signal. How we can get the value of A? Basically, we have modified the carrier signal amplitude EC, or we have varied this EC in proportional to EM signal, that is the modulating signal. Here proportionality constant we have assumed as unity. So we can now write down the expression for AM signal. That AM signal is given as this AM signal is given as A cos 2 pi fct. We have not changed the frequency, we have only changed the amplitude, and this amplitude is EC plus EM T cos 2 pi fct. This is the third waveform generated after the process of amplitude modulation, which is AM signal, which is representing AM signal. So we can write down this signal in this way also. Take this EC as common, 1 plus EM T. This is divided by EC. This is cos 2 pi fct, which can be further written in this way. EC 1 plus EMT is EM cos 2 pi FM T. This is EC, and this one is cos 2 pi fct. So this can be written as EC 1 plus this ratio of EM and EC is basically modulation index by definition. So this can be in terms of modulation index, amplitude modulated signal. We are going to write down in this way. So this signal is AM signal. This signal is AM signal in terms of amplitude modulation. Amplitude modulation. So in terms of modulation index. So where M is ratio of amplitude of modulating signal to carrier signal. So this is the expression obtained by the modulation process. This can be further written in another way by using trigonometric relation in following manner. This signal is, so this AM signal, which is basically amplitude modulating signal, removing the brackets. So we can write down this in this way. First component is carrier signal, then this M into this M into EC cos 2 pi fct into cos 2 pi fm t. Suppose this is multiplied by 2, then it is also divided by 2. This is done. So we will be able to use this relationship of trigonometry, this cos A into cos B. which is equal to cos A plus B plus cos A minus B. So in term, by using this, we can write down the amplitude modulated signal in this way also. First component is EC cos 2 pi FCT plus. Second is M EC divided by 2, and this can be written in this way: cos FC plus FM T. This is T. This is cos 2 pi FC minus FM T. So this is the expression for amplitude modulation, modulated signal, where we can note down three components. One is carrier signal. This is second term. This is third term, which is representing upper sideband and lower sideband respectively. So in AM signal, we have three components. One is carrier signal. This carrier signal is EC cos 2 pi FCT. This first component is carrier signal. Second signal is representing upper sideband, and this is equal to M EC by 2 cos 2 pi FC plus FM. And third component in this AM signal is lower sideband, which is M EC by 2 cos 2 pi FC minus FM. So this is the analysis of amplitude modulated wave, which consists of three components. One is carrier signal. The second one is upper sideband. FC plus FM this is representing upper sideband, and third one is lower sideband. One important thing we can note: this upper sideband and lower sidebands are symmetrical. In previous classes, I have covered the concept of upper sideband and lower sideband. But one thing here we can note down: this is representing amplitude. This MEC by 2 is representing the amplitude of each sideband. So this amplitude is dependent on modulation index. So this amplitude of upper sideband and lower sideband is function of modulation index. So in next class, we will calculate the power contribution from carrier component, power due to upper sideband, and power because of lower sideband. Then total power will be PT is equal to PC plus sideband power. For this, we will calculate power contribution from carrier and power contribution of each sideband, upper sideband and lower sideband. So we will continue in next class. So thank you very much.